First derivative test is used to find the relative maxima or minima or local maxima or minima. If you take a function graph, we can see somewhere is taking concave down, somewhere is concave up, somewhere is not differentiable and maxima, somewhere not differentiable and minimum. So here you can see that it is concave down. So concave. So there is a space that is means concave down. Similarly, this will call as concave up. Concave up. So this is called relative maximum. This is called relative minimum. Here we are not able to find differentiable, non-differentiable. Relative maximum, non-differentiable, relative minimum. Now we can find these points where is maxima or minima using first derivative test. Suppose I am taking one concave up graph. Sorry, we will take concave down first. So this is your concave down. Now, if you draw a tangent here, this tangent is making an angle theta with your x-axis. This theta is acute. Therefore, tan theta is positive. But we know that tan theta means dy by dx, rate of change of y with respect to x. So dy by dx is greater than 0. When you draw a tangent on right side of this concave down graph, we can see that this is tangent is making an angle phi with x-axis. Phi is obtuse. Therefore, tan theta is negative. We know second quadrant tan is negative. Therefore, dy by dx is less than 0. Here at this particular point, if you take a tangent, we will see that tangent is parallel to x-axis. Therefore, dy by dx equal to 0. So dy by dx is changing positive to negative. Then at this point we can say that one is relative maximum value, and point of relative maxima is this point C. Similarly, if you take a concave down graph, concave up portion of the graph, if you take a point here, left side of this point, C2, we can see that this theta is obtuse. Therefore, tan theta is negative. Therefore, dy by dx is negative, less than 0. Similarly, if you take a point on right side of this C2 and draw a tangent, this also make an angle phi. Phi is acute. Therefore, tan phi is negative. Therefore, dy by dx is so positive. Therefore, dy by dx is greater than 0. When you take a tangent here, we can see that it is parallel to your x-axis. Therefore, dy by dx equal to 0. So it is changing, dy by dx is changing from negative to positive. Here dy by dx is negative, here dy by dx is positive. So dy by dx is changing from negative to positive at this point, left and right side of this point. We will say that one is local or relative minimum. So C2 is the relative or local minimum. Now we will see here in case 1, concave down, dy by dx is changing from positive to negative when the point value of x is increasing over C1. Then we will call it is relative maximum or local maximum value. We have seen already from the graph, it is a maximum value. So for finding out this point, first we will take dy by dx equal to 0. Second, if its change in dy by dx is greater than 0 in left side of C1 and dy by dx is greater than 0 in right side of C1, then C1 is the local point of maximum. Now we will see some example and we will see how to find out apply the first derivative test. So we will take first example. I am not taking the function, I will take the derivative, then I will explain the process. So suppose dy by dx you got as 4 minus x squared. So first we have to find out the critical point or stationary point. For that, dy by dx equal to 0. So we will get 4 minus x square equal to 0. Therefore x square equal to 4. Therefore x equal to plus or minus 2. Now we have one point x equal to 2, one point x equal to minus 2. So we will see that. We will draw x dy by dx. So you will get x equal to 2. I am writing here middle of this. Now x equal to 2 means we have seen dy by dx equal to 0. So it is parallel to x-axis. So I just draw a straight line. Left hand side of 2 we have to take 1 point. Let it be 1. Right side of 2 we are taking 1 point as 3. Now when you substitute x equal to 1 in dy by dx, we will see 4 minus 1 square, 4 minus 1, that is 3. It is positive. So positive means your tangent is making acute angle. So I am drawing one line like this. This means that tangent is making acute angle, this direction. Now x equal to 3, 4 minus 9 square, 3 square, 9, 4 minus 9 is negative, so negative. So tangent is making acute angle, so we will draw a line like this, because we know that one tangent is making obtuse angle like this, negative. So you got a shape, see, like this. So this shows that it is here concave down. So this point is maxima. So therefore x equal to 2 is relative point of maximum. Then you have to find out maximum value equal to your function at that particular point. What is the value? Now we'll take another x, we'll take x equal to minus 2. Second value is x equal to minus 2. Again we'll draw x dy by dx. So minus 2 will mark in middle. Left side of minus 2 minus 3, right side of minus 2 minus 1. Minus 2 means we have seen it is parallel, so dy by dx is 0, straight line. Now minus 3, 4 minus 9, that is negative. Negative means here obtuse, so tangent is like this. Now minus 1, 4 minus 1 square, 4 minus 1, that is positive. Positive means your curve is like this. Now see, you got the shape like this. This is coming in concave up. Therefore, this point is relative minimum value. Therefore, x equal to minus 2 is relative point of minimum. Minimum value is f of minus 2. Now we will take another example. Dy by dx equal to x minus 3 whole square. Now first step, dy by dx equal to 0 implies x minus 3 whole square equal to 0, implies x minus 3 equal to 0, so x equal to 3. Now we have to see it is taking relative maxima or minima. For that, again we are making x dy by dx. So you got the point 3 where the tangent is parallel to x-axis. Then left side of 3, 2, right side of 3, 4. Now 2 means 2 minus 3, minus 1 square, positive. So you are getting like this. Now 4 means 4 minus 3, 1, 1 square, positive, again this. See, you go getting like this. So this is increasing, again increasing. So this will give the point of inflection. Therefore, x equal to 3 is point of inflection. This point of inflection I will explain already in one video. So we can refer again that x equal to 3 is point of inflection, because both there is no change from positive to negative or negative to positive. You are getting that one both is positive. So there is no change. Therefore that point is called point of inflection. So another example, dy by dx equal to minus of 4 minus x whole square. Now see, dy by dx equal to 0. So here 4 minus x whole square equal to 0. So x equal to 4. Now again we are seeing x dy by dx. So 4, left side of 4 3, right side of 4 5. 4 means we are getting 0. Now 3 means you are getting 4 minus 3, 1 square, that is negative. Negative means this obtuse. Similarly 5, 4 minus 5, minus 1 square, again negative. So your graph is coming like this. So therefore x equal to 4 is point of inflection. So here also there is no change in dy by dx sign. It is from negative to negative. So it's a point of inflection, not giving any local maxima or minima. Now we will see one more example. Already seen here is non-differentiable here, but still we are getting relative maxima. Non-differentiable, still we are getting relative minimum. So we will take example f of x equal to 3 plus absolute value of x, where x belongs to R. So we know that absolute value of x is not differentiable. Therefore 3 plus absolute value of x is also not differentiable. This is here 3 plus absolute value of x graph. So it's not differentiable at x equal to 0, because when a 0, left hand side derivative is negative, right side derivative is positive. So we'll get f of x equal to 3 plus x when x is greater than 0. Since absolute value of x is x when x greater than 0, absolute value of x is minus x when x is greater than 0, less than 0, therefore 3 minus x. When x equal to 0, absolute value of 0 is 0, 3 plus 0 is 3. So we'll find out what is f dash x now. So f dash x when x is greater than 0, derivative of 3 is 0, x is 1. Sorry, 3 is 0, x is 1. So 1 when x is greater than 0. When x is less than 0, derivative of minus x is minus 1. So it is minus 1 when x is less than 0. When at x equal to 0, it is not defined. We don't know. But we want to see that it will take maximum value or minimum value. From the graph itself we can identify it is taking minimum value, there is no maximum value. But still we will see the first derivative test. X f dash x. So here you are getting 0, it is not defined. Left hand side -1, right hand side 1. X less than 0 means we got it negative, so graph is like this. Again x is 1, x greater than 0 means 1, so it is positive. So you can take acute. So we get the graph is like this. So this means it is taking local or relative minimum at x equal to 0 and relative minimum value equal to we got it f of 0 that we have seen already 3. So minimum value equal to 3. Thank you.